This question is about some particles colliding, quite a common thing in the further Mech paper. So we've always a good idea to get an idea of what's going on. So before, I've got my two particles, P and Q. P is moving one way and Q is moving in the opposite direction, so they're going to collide. And then we're going to have an after. P, Q. Okay, close with Q. P is reversed. Now, they don't say anything about what happens to you. Oops, not for you. Just call that its velocity afterwards. They don't say anything about what happens to Q, so you just have to have a sensible guess. I'm going to put that Q also rebounds. That might be a fairly sensible guess as to what happens. If you don't, all that happens is you get your sort of speed as negative. Obviously, speed doesn't have direction, so that doesn't matter. You can deal with that at the end and just turn it into a positive. Okay, so we want the speed to meet the after collision. So colliding particles, there's always two things we look at. Conservation of linear momentum. With this, just make sure you choose which way is your positive direction and then keep it consistent. So m times v, so that's for P. Now Q is moving in the opposite direction, so that has mass 3m and speed u, so that's before. Now after, they both reversed, so P is now moving in the negative direction and Q is moving in the positive direction. You can then simplify that equation and get to 2 velocity of P minus 3 velocity of Q equals negative 3u, and that's going to be my first simultaneous equation. The other thing we're going to look is at the coefficient of restitution. So it doesn't tell us anything apart from the fact that it's E. So that's going to be the speed of separation. Now on my diagram, they're moving in opposite directions, so the speed of separation is added. If you had them moving the same way, you'd have to do a subtraction there. And also, they are definitely, whichever situation you have beforehand, they're approaching each other. So their speed of approach is 3u plus u. This can be rearranged to give me the equation Vp plus 3q is 4ue, and that's my second simultaneous equation. Now all you've got to do is solve these, and we want to end up with the speed of q, so in my equation that's vq. So a sensible thing to do, for example, is equation 1 minus 2 lots of equation 2, which gives me negative 5 velocity of q, negative 3u, negative 8ue, which obviously taken all the turns to pluses, and then you can rearrange that to get the given answer. I should probably show a little bit of working as it is. I show that. Okay, the next bit is we want to find out the possible values of E. Right, just give us a bit more space there. So that was part A. Right, part B. So we want to find out what E could be. Well, what do we know? We know from the question, we definitely know which direction P is moving in, and we can work out that the velocity of P is going to be 3u over 5 times 4e take away 1. So that's if you use your original simultaneous equations. I've just made those a little bit small now, so you can use either one of those. For example, this one tells us the velocity of P is 4ue minus the velocity of Q. Okay, so now I've got velocity of Q and velocity of P. Well, what do we know? We know that both of these must be greater than 0. So, for example, using velocity of P, that's got to be greater than 0. So obviously 3/5 is greater than 0. U is greater than 0. Because that's set up in the question. It says it has speed u. So 4e subtract 1 must be greater than 0, which gives me that e must be greater than a quarter. You can do the same for velocity with the velocity of q, and you can get that e is greater than 3/8. The smallest of those two, the lowest value of that is a quarter, and e being greater than 3/8 is taken care of there. You also then have to remember that the values of e go between 0 and 1. So using our inequalities and combining this, that's not the full answer, because e has to be greater than a quarter, but it also has to be less than or equal to 1. So don't forget that bit. Okay, so final bit is just working with kinetic energy. So we've got the kinetic energy before is T, and the kinetic energy afterwards is K times T, and now they're telling us that E is a half, and they want us to find out what K is. Well, so this one, we're usually pretty good at dealing with kinetic energy, so kinetic energy is a half mv squared. I can then find kinetic energy before. Okay, so I just deal with both particles, so a half Q has mass m, and before, if you go back to your before diagram, it's got v3u, and a half particle Q has mass 3m, and before it has the speed of u. Now it doesn't matter about the directions, because if you square a negative velocity you're going to get a positive anyway. So that's t, and if you simplify this side you can get 21/2 mu squared, and it said that was called t. Okay, afterwards it's k times t. So kinetic energy after. Now we've got a half 2m. Now our expression was 3u over 5 times 4 times e, so e is a half minus 1 all squared, and then the same for q. Whoops, so that's supposed to be a half. That's 3m. Okay, so this was u over 5 8e plus 3 all squared. Okay, that's with subbing in e is a half. We're told that's k times t, so you can get that that's 33 over 10 mu squared if you simplify that side. Okay, so k times t, we know what t is. T is 21 over 2 mu squared. Must be 33 over 10 mu squared, and then it's quite easy to rearrange that and get that k is 11 over 35.